Okay, it's probably going to be the longest video we've got here, guys. Scientific notation. So when we're adding or subtracting, so adding or subtracting, so kind of on these two, you have to match your exponents, right? So I'm going to shift my decimal right here, which causes this exponent to go down by 1. So this becomes 84 times 10 to the 6th plus 6 times 10 to the 6th. Okay? Now, this 84 plus 6 gets us to 90 times 10 to the 6th. You just add them together, right? Because when it's the same exponent, yep, it's both 6. You can just take your coefficients out front and multiply them together. Okay. So then we have to shift our decimal here by 1 to put it back in scientific notation. And as we shift it to the left, we're going to add 1 right here, right? As we shifted it to the right, we subtracted. As we shift it back, we add a back in. In this case, shouldn't be a 7. I don't know why that looks like a 7. That should be a plus 1. My bad. Because I was thinking 6 plus 1 is 7. That's why. So this becomes 9.0 times 10 to the 7th, or just 9 times 10 to the 7th. Okay? Now, when you're multiplying or dividing, you do not have to worry about switching. You don't have to worry about matching up your exponents when you're multiplying or dividing. That's just for addition and subtraction. Okay? So this one, you can just kind of match these up. So 3.3 times, let's use that to represent that multiplication, and then times 10 squared times 10 to the 6th. Right, so I match these up here and then these up here. So I'm just going to use a calculator. 3.3 times 4.1. Right, double check that. Let's see. 3.3 times 4.1. 3.3 times 4.1. Come on. Gets us 13.53. Okay, and then 10 squared times 10 to the 6th means 10 to the power of 2 plus 6, which is 10 to the 8th. Okay, now, not in scientific notation until we move our decimal. Since we move it to the since we move to the left by 1, we add. We add 1 right there, so that we end up getting 1.353 times 10 to the 9th. Okay. Very similar situation right here. We take this 9.6, we're going to divide by 3, okay? And then we multiply by 10 to the 14th divided by 10 to the 5th, okay? So see 9.6 divided by 3 gives us, did I get that right? Let's see, 9.6 divided by 3, 3.2, that's right, okay. So 3.2 times, now when you have this, all that's going to happen right here is you've got this 10 to the 14th, you just subtract the 5 from it. You keep the base, subtract your exponents. So this becomes 3.2 times 10 to the 9th. And since it's already, your decimal's already in the right place for scientific notation, we don't have to do any shifting of decimals, okay? Here's the big daddy, guys. All right, so this looks easier than it is, right? And it's easier than you think because we already have matching decimals for our addition problem. So what we can do on top, right, we're just going to match that 7 plus 5 and multiply it by that 10 to the negative 5. And we still got that 4 times 10 to the 6th on the bottom, okay? Now we add these together. 7 plus 5 gets us 12 times 10 to the negative 5 over 4 times 10 to the 6th, okay? Now we divide. 12 divided by 4 is 3. And then we've got this 10 to the negative 5. And since it's division, we subtract our exponents. Okay. Oh, man. Oh, God. I did not organize this problem very well at all, guys. Negative 5 minus 6. When you start with your calculator, okay, I think this is the first time we really dug into the negatives. You're going to put your 5 in and make it negative. Okay, so negative 5. Right? Negative 5 right there, and then you subtract 6 from it, and you can see it's negative 11. Now, We're going to leave it like that, guys. Just 3 times 10 to the negative 11. Kaboom. Okay? All right, there you go.